I'd like now to introduce as our second keynote speaker, Professor Zeqi Qiu from the Peking University, where he's a professor in the Department of Sociology and the Boyer Distinguished Professor. He's also a director of the Institute for Digital Governance. Please welcome Professor Zeqi.
It is a great honor to stand over here to share some of my considerations about the AI and the researchers. Many thanks for the DI idea and the DFID invite me over here. I will share some of my considerations about how the humanities and the social science use AI for enhance their capabilities as a professor or even as a tutor. Alina actually just discussed about one of the relationship is that the student and the professors. Students can learn from the AI, and what they can learn from professor. The professor must have some of their own capacity to provide the knowledge, also the discussions with the students, and where the knowledge comes from. And then using AI as a tool, or even as an instrument, even as a subject to interact with human beings, especially for professors, is very important in the AI-aged time. So here I'm going to discuss about 3 pillars. So this is the basic thinking about the AI for academia. And on the left column, we'll see the intelligence. Now we do have 2 intelligence. One is the human intelligence, which actually is about 1,000 years, even we can say 10,000 years with the human beings. So all of the development we have today majorly come out from the initiative or the initiations of the human beings. However, machine actually have the intelligence right now. We do use the machine itself actually as the human beings start to use the tools. Start from the stone tools and then up to what we call the mechanical tools, and then what we call the computational tools. Now it's the AI, the artificial intelligence. So machine intelligence actually come in to join the human beings as a part of the intelligent or intellectual creations. And how this intelligence can be joined the human beings, I think there's a 2 way. Actually, it's the AI thinking or AI path in the debate of the artificial intelligence. So in the middle column, we'll see a table that's actually we have 4 cells in the middle. Now, if we think about the intelligence as a machine intelligence, that's external intelligence, we do have 2 ways to think about it. One is we think about the machines do things or think things like human beings. This, I think, is one of the schools right now in artificial intelligence evolution. The second is just to take the machines as a rational machines or rational instruments, which actually took the machines as an instrument itself. And if they do things like the human beings, that is a behavior, and what they do, what they're thinking in the considerations, what we call the internal thinkings. So actually that's departed also of the intelligence in 2 ways. One is external way, the other is the internal way. So if I think about like human beings or unlike human beings, that's the behavior and thinking, which we have the 4 cells in the middle. And how these ways being actually integrated into AI for academia, now we actually have 2 parts. One is the AI for science. The other part is outside or apart from the AI for science, there's AI for humanities and the social science. We know that human knowledge is, at the very beginning, is integrated knowledge, not disciplinarized the knowledge. The disciplinarized knowledge is based on what we call the scientific revolution. This starts with the Enlightenment in the Middle Age. So these things happen today Even we sit over here, it's based on the education. You see, when our president of Hampton College says about the education, actually it's one of the disciplinaries, which is not a part in human knowledge before the enlightenment. So that is the ways. I put times rather than plus in the middle. This is because the human intelligence is not plus the human intelligence. They actually interact with each other, which sometimes will produce the effects like times rather than just a plus. It is also like the AI for science and the AI for humanities and the social science. This means they are not a part of each other. They are actually being interactive with each other. We are right now, it's the reality right now. If we think about ways and then what ways we can use, what ways we can do, I quote a proposal of the Dartmouth Summer Research Project on Artificial Intelligence in the 1960s. In that proposal, actually set 7 ways for using or for development of the artificial intelligence. First, it's a computation. Low computation, low AI, low artificial intelligence. So how the computer being accompanied with the intelligence of human or intelligence of machines. Coding is one of the important. Whether it's a simulation or whether it's do rational things, it's still be a debate topic right now, but the human brains is the machine or not, because we do not know exactly what's the mechanisms inside our brains. Second, since it is interactive with human, so human language is one of the important, what we call the API. It's a cutting point. It's a rooms for interacting with human beings. So the machines should learn the words of using and also the language using. This is where LLMs come from. The third is the neural networks. This is one of the assumptions for the human brains. So whether the human brains is a network or not, we are not sure yet, but it assumes that the neural network is one of the mechanisms. So neural network in human brain is the basic for what we call the language, the multiple language models right now. The first way is the complexity of the computings. We trying to measure in the complexities and also trying to enhance the efficiencies and use less power, especially for the electronic power, to generate more knowledge by using the computations. And the fifth is for iterate of the models, that's a self-improvement in efficiency and also in task achievement. Sixth is quite important. Now, also, it is hard to let the machines to make abstractions. It is something like to put impossible tasks for the machines or even for the human beings. This is why the students need to join school, need to learn from the elementary school, go to the university. So this is kind of, I think, the abstractions is the most important for the knowledge and the knowledge heritage. The seven is trying to simulate human beings. Let's ask questions or answer questions by random, also by creativities. This is one of the human thinking, and we also ask the human intelligence to do as it. So this is the ways, and in the last 40 to 60 years, we see the AI being used in the researches. And that article actually measured about 333 disciplinaries or fields which used AI in the last 40, I think it's 1960, no, it's about 60 years, 1960 to 2020. So this number and the curve, we see the right line below, I think it's the second line of the bottom, there's a social science. Comparing to the others, the index is not so high, but we see in the 2020 and 2021, it increased dramatically. That is the trends happened in the humanities and the social science. What we can learn from the other side, that's AI for science. And I quote one of our colleagues, that's Wang et al., and the others who actually have a summary, have a literature review trying to present the current situations of AI for science. It is summarized for 4 dimensions. First of all, they see the AI actually helped for the science, for the scientists in the data collection. And we know that data in the science is basically is based on the experimental data, machine data, and also the records, and how the AI can help the scientists to refine the data and annotating the data and also select the data. And this is real right now in the scientific fields. The second part of that, the AI for science, is learning meaningful representations of the scientific data. We have a mass of the data, we have many or massive of the data, different model of the data, and how this data have been really mean for some of the subjectivities or some of the themes. And there are 6 points what's being used in the scientific field. The first is geometry prowess. The second is the geometry deep learning. We know the deep learning actually is being used for scientific data learnings. The third is self-supervised learnings. This is another model of what we call the algorithm used in the data learnings. The fourth is language modeling, which actually is trying to moderate the different specialized disciplinaries. The fifth is one of the algorithm model. It's called the transform architectures, which is being used for ChatGPT and the majority of what we call the big models. The final one is the neural operators, which is trying to simulate the human brains, but I'm not so sure right now it's the real mechanism of our human beings really like a neural networks. The third dimension of AI being used for the AI for science is the AI-based generations of scientific hypotheses. We know that scientific research is based on a hypothesis, sometimes based on the discovery or data mining, but the hypothesis still being the major trends or the major part for the scientific research. We know some of the AI-based hypothesis generating is based on a black box. So how the black box has been predicted scientific hypothesis, we don't know yet, but it can do. Sometimes it has been done. And the second is leveraging the compilation of the hypothesis with the species. It's been used especially for Earth and the space sciences. The third is optimize and differentiable the hypothesis species. The human beings, we do the hypothesis and also give the hypothesis, whether the hypothesis has been predictable or it is good or not. And AI can help us for make a judgment. The last one I think is quite the most important one is AI-driven experimentation and simulations. We know that the scientific field is based on the experimentals and the experiments, and how we do the experiments more efficiently and more precisely for some of the hypotheses. The AI actually has the capacity to help the human beings, especially in the simulations. I'm going to say something about the simulations later on in the humanities and the social sciences, which actually enhance the efficiency. Also, these are trying to predict more precisely for the scientific hypothesis, also deducing the observable from the hypothesis used in the simulation. That means the resource efficiency. And this is AI for science right now. I mean, also is the up-to-date progresses in the scientific field. And then what is really happened in the scientific field, we found out the AI actually has been used for math, for chemistry, for earth and space science, also for programming and psychology and drug selection, and also engineering in some areas. We have some of the AI applications in science for specialized AI applications, for example, alpha geometry, alpha folder 2, and the graphimal, and the ID4NOs. This is for the different disciplinaries, which is specialized for the discipline usage. We can also find some of the general applications in the GPT. That is something like a market. It's an app market in the GPT. Something like you're using the iPhone. You know the iPhone, you have an app store. There's a lot of apps in it. And if you use the Android, you have the Google Play. There are a lot of the apples in the Google Play. And also there's applications in the GPT, so you can find that right now. For humanities and the social science, and then what we can do. We know that for humanities and the social sciences, we have 3 very important elements, which is like the science. The humanities and the social science are actually the same in terms of the scientific, in terms of the scientific paradise. And that is a data, methodology, and theory. If we think about these 3 elements, which transfer into the AI age, using the AI, I think about there's 3 things we can do right now. That is, the first is AI-aided data integration. The second is AI-based facts analysis. The third is AI-driven theory building. That's really new things for humanities and social science. First of all, for AI-aided data integrating, so what does that really mean? It really means making all data computable. So this is a kind of a revolution. When we say about the data computable, which means you can mine in the meaningful things in the data, but it must be computable in parallel conditions. And how can we do that? I try to divide it into 2 parts. First of all, is the humanities, the second is social science. In the left column, we have different colors for the text. In gray text is the traditional humanities in using the data. For example, text, images, entities, and also the materials. For example, architecture, the archaeology findings, or something else. The second is language, music, and dance, rights. That is human activities or human communications. Humanities is trying to use survey data and the statistic data when the measuring or the measuring science being used for the social sciences. For example, the statistical history, also or the analytical philosophy, they are trying to use the survey data and also the statistical data, even the mathematics, the math. And here we see that's not possible before the AI joined the humanities research. In the other part, for the social sciences, we know the text and image and entities. I mean, the other of the same materials or the same data is something like the humanities being used in the past centuries. And it is developed by the scientific revolution that developed the new data is the survey data and the scientific data. But now, what I'm saying is that generative data in both humanities and the social sciences not happened before the AI coming to the age. And this is why I'm saying that generative data is more important. This is because the data is not available for the researchers. It is actually accumulating in the government, United States government, the Chinese government, UK government. They actually host a lot of data, but they are not released for the academic research. And also for the companies. In China, we do have many companies, Alibaba, Tencent. They actually host a huge number of the data, and they collected all the data. However, none of our scholars can collect that kind of data today. So the scholars actually exclusive from the data. So little data is quite important. One of the ways is trying to let AI generate data itself, which can simulate for the real world, for the real human beings. This is why I'm saying making all data computable. And one of the things is different from the science. That is, for humanities and the social science, we have many archives which actually accumulated 1,000 years. And I illustrated 3 pictures over here. On the left, this is quite important, something like an encyclopedia in China, which in ancient China, that's Yongle Dadian. It's a huge bunch of the books, like may accumulate like this room. And this really huge. And all of the characters which printed in paper and not recognized by the computer. Now, maybe I think it's almost 100% of those classical workers being scanned into the digital way, but not in the computable way. This is because if you try to light the computer using that kind of data, you have to annotate most of the words, also trying to flag most of the words what they exactly mean. On the right hand, the up part is one of the famous paintings in China. We actually in Zhejiang University scanned about I think it's about 100,000 of the famous paintings in Asian for Asian Chinese paintings, which accumulated about terabytes of the data about that. But also, this is just transferring the paper side to the image size, larger digital size. So if we're trying to use that data, we need to annotate it to make it more numeric. And the black one is the loose you may see. I think that the notes over here you see, first of all, this is varied in the Vosvos challenges in the Greek, which means the purple. That means they use the AI help to read most of the rote of the archive and trying to identify those of the words. This is really frontier advances. Make that readable and visual to computable is impossible task if we're without the AI aids. And the other part is quite similar, also it's different from the science, is we have another side of the data, is the paradata with the human behaviors. And you do things, you generate the data. And also you generate your footprints. And even with the data, even those of the data in a numerical way, but it's not computable. So make that computable is really important. Also, it's good, and also it's important for the computational social science. And then for the AI-based facts analysis, I also have the 2 columns. First, because we are in the humanities and the social science, there are 2 ways to use the data, the numerical data. One is the hypothesis testing, which actually is happening in the, what we call it before the AI age. I'm in the field of sociology. Statistics is the basic capacities of the sociologist. So we use the hypothesis testing in our survey data. But now, maybe we can use the algorithm-based statistical hypothesis testing. It's more efficient, more precise. Also, we can use the other way, that's agent-based modeling, that is a set loads of the k variables, set loads of the models, running themselves like human beings. That's what we call agent-based modeling. So simulations are also happening in the social science in the last 30 years, but now, also it is quite popular right now. I myself doing what we call the empirical studies combined agent-based model, and it's quite successful. However, even we have 2 ways to use the hypothesis testing. One is agent-based simulation, the other is hypothesis testing. However, the algorithm-based mixed data model and also the massive data is one of the tasks we face. The second way is we do not have any hypothesis, we just based on data. So data mining is a lot of ways right now used in humanities and social science. So algorithm-based pattern modeling discovery And also the algorithm-based pattern modeling refinement, just like the AI for science, is the same ways used in the humanities and the social science. All the ways will be joined together to make all of the relevance included. Why I'm saying that is because before the AI coming into the humanities and the social science, we actually use the small or few of the parameters, for example, 10 or even 20 of the independent variables. But now the independent variables come into billions, 100 billions, something like that. So that's a different ways. And the third, also is the most important way, is trying to have a theory building. We actually in the social science, especially in the humanities and social science, have two ways to build this theory. One is the interpretive, the other is the empirical studies. Especially in the American way and in Chinese way, in the sociology, empirical ways is the important ways. And the interpretive ways, especially in the European countries. And now we know that AI-driven interpretations of the human and social phenomena is still happen, is still be important to make people feeling meaningful for their lives. So AI-driven initiation, not just initiative, it must be initiation of the phenomenon interpretation, becoming more and more important to find people like just our dean said, and make the AI surrounding the people. So a human-centered AI is like this way. So I have to say that AI-driven, the meaningful mining of the phenomena is coming to the age. For the empirical studies, we know that AI-driven pattern is explainable. For example, education and the social structure, education and the social movements. That is a kind of a way to interpret the patterns of the education and the social structure. Also, the second, the AI-driven pattern modeling is predictable. This is for social science, especially for social science. If you don't know the causals, you don't actually even do the social science. Prediction is important for social sciences right now. So the AI-driven macro and the macros is important for our intact repo. We know that the macro and the macro is tough. Also is something like difficulties for the social science, but now is the way and it's the time for that. So this is why I'm saying that making human and the society more understandable, not just for the scholars, but for the general people, for the commons. And how can we do that? I have a question also I'm trying, I myself tested in a few years ago. We know that one of the anthropologists in Oxford University, not in this university, Robin Denver, have a very famous, what they call the social media numbers. That's called the Denver number. And he actually predicted that it is about 148 of the contacts, the maximum number for one individuals for they can manageable. And the most close and frequently contacted number is about 20. And then it's a real lot. And my professor, the Fei Xiaotong, who actually got his PhD in the LSE, he described of the Chinese society to say the Chinese people make their contacts, make their social, is something like you drop a stone in the water, you can see a circle by circle, something like that we call the 差序格局. So we have numbers, first of all. The second, we have patterns. And then, what's the number in the pattern? We don't have an answer yet. So I tried to find the answer. So we used WeChat in China. I asked the president of the WeChat, Zhang Xiaolong, give me a set of data for experiments. I asked for 1,000 of individuals with 300 contacts. Why 300? It's because Robin Denver said it's about 148. So I just double it for 300s. So that is a matrix, 300s by 1,000s. That's just by random number. I dropped it from, I think it's about 1 billion of the users. And then we found out we have a very special pattern. And what we're measuring that is we calculated people to use their spirits, which means your time. You the share of your contacts. If you have 70% of the share, which means the majority of your resource about social media being occupied by a certain number of the people. So that's understandable. So you can imagine in China, what's the percent, how many people occupied about 70% of your resource of the communication? Just a 2, you see the mode. The mode is only 2 over here. Sorry, I don't know what, yes, that's a 2. Mode is 2, the medium, you just said the medium is 2. Even with the 90%, you got only 2, 3 and 2. Which means in China, the social communication is a very small core. 2 persons occupy your 70% of your resources of your communication. This is far fewer than 20, as Robin Denver said in his famous numbers. So if I myself, I'm an ordinary person, I try to let the AI help me say, can you let me know who occupied my resources? We use that algorithm just put in the, what we call the WeChat, and the WeChat may answer you. You just have 1 person or 3 persons. And you can judge yourself, and you can adjust yourself. The resource may be more heterogeneity, more homogeneity. We don't know. But it's AI-powered services, knowledge services for human beings. So here I have the third. AI is not for education in forms of a formal education, but in the daily life. It must be powered in our daily powered instrument. For example, your cellular phones. You do whatever you want, and then you can ask, where is your resource spending? How can we achieve that? So using AI-powered research is one of the only way I think we can do for that. For summary, we will say that's the 3 pillars I'm saying. AI actually helped us to get data integrated, not just for numeric data, also for text, image, video, visual, and other things. It's a mixed data. We used mixed data, integrated them for generate with our new methodology, generative knowledge, not just for few scholars, but for the common peoples. I think this is a new way for the value of the scholars, especially in the what I call the digital society. So here, imagination is becoming more and more important than any before. I think this is the most important if we teach our students to do things better, to do things good. That's the imagination. We can use the data, we can use the AI for data, we can use the AI for patent funding or discovering, but imaginations must be interacted with the human intelligence times with machine intelligence, not the human intelligence itself. This is why I'm called the 3 pillars. And here we got patterns right now. That's imagination. Integral the way is data, makes the data, also the algorithm, and we have a 3 eyes model, which is imagination for human and social goods, just like all you agree, and the AI is an instrument, or AI is something like a tools, it's a server for human beings. Second, it's an initiation in collecting and using data as something like instrument value, or the tools value. Third is integrated with human and the machines. This, I think, is the future way for the AI-powered humanities and the social science. And this, with the time Excel, we can find is coming to the age right now, especially for today's. Thank you so much. Thanks.